In this video, we want to continue our discussion of evaluating limits algebraically, particularly using the strategy of rationalizing. Over on the right side, I've listed some different techniques that we use to evaluate limits algebraically. The first one always being direct substitution. In this case, we would just take x equals 0 and plug it into the expression. In this case, when we do that, though, we end up with 0 over 0, which tells us that we have an indeterminate form, and we're going to have to find another method of evaluating the limit. The second strategy is factor and cancel, but there's nothing to factor in either the numerator or denominator, so there's nothing to cancel out either. The third method, which we use usually whenever we see radicals or a radical expression in a limit, and it's based on what we learned in Algebra 2 and Pre-Calculus about rationalizing denominators. For example, if we had the expression 1 over square root of x plus 2, and we were trying to rationalize or to get rid of the radical in the denominator, then we would multiply the top and bottom by the conjugate of the radical expression. In this case, that would be square root of x minus 2 over square root of x minus 2. And when we multiply that out, we're left with square root of x minus 2 over, and the denominator now becomes a difference of two squares, which is first term squared minus second term squared, or x minus 4. So we're going to use this type of procedure to help us simplify our limit expression. So in our case, we have square root of x plus 5 minus square root of 5. The conjugate of that would be square root of x plus 5 plus the square root of 5. And we're going to multiply numerator and denominator by that expression. And when we do that, we have limit as x approaches 0, the top becomes first term squared, x plus 5, minus second term squared, 5, all over x times, we'll have a much more complex denominator now, x plus 5, square root of x plus 5 plus the square root of 5. But we can see that the numerator will simplify, the 5's will zero out, and we will end up with limit as x approaches 0 of x over x times square root of x plus 5 plus square root of 5. At this point, our x's can cancel, and that's great because x in the denominator, the factor of x, is what caused the denominator to become 0 and hence undefined. Now we've gotten rid of that. We go on simplifying, limit as x approaches 0 of 1 over square root of x plus 5 plus square root of 5. At this point, we can use direct substitution. We plug in x equals 0, and we get 1 over square root of 5 plus square root of 5, or we have 1 over 2 square roots of 5. And so that is the limit of that expression using the method of rationalization. And again, this is helpful whenever we have, often helpful whenever we have a radical expression in our limit. Right? So you can try this with other types of problems. And I've just put some more onto the workspace there, and you can see that problem 54, 55, 56, they all share similar features with the one that we just did, and the method of rationalization would help to evaluate those limits. Okay, we'll stop at this point and go on to a different topic.